3. We have the quantity 1 plus log x plus y over x times differential x equals the quantity 1 minus log x times dy or differential y. Recall the exact equation will be in the form of m dx plus n dy equals 0 or in the differential of the solution form. Now we are going to rewrite the equation by subtracting 1 minus log x dy both sides to get the other side be 0. Then we have 1 plus log x plus y over x dx subtracted by 1 minus log x dy equals 0. I'm going to rewrite it in the better form. The first term or the term of the m will be the same, but I'm going to write the second term as plus sign of natural log x minus 1 dy equals 0. Now we see the m as 1 minus log x plus y over x and the n is log x minus 1. Next, we are going to check whether it's exact or not by finding the partial derivative of the m with respect to y. Then we get 1 over x and also find the partial derivative of the n with respect to x. We get 1 over x as well. Therefore, this equation is exact. And next, we are going to find the solution from the definition of the m as the partial of the solution with respect to x. Excuse me. And the n is the partial of the solution with respect to y, or natural log x minus 1. We are going to use one of them and find the antiderivative to get the general solution form out. So I'm going to use the n function. So f of x, y equals the antiderivative of natural log x minus 1 quantity with respect to y plus the function hx as the constant of integration. Therefore, we get y times log x minus y plus h of x. And next, we're going to use the function that we obtained. Find the partial derivative with respect to x and equate to the m expression. So the partial derivative Example 3, 1 plus log x plus y over x times dx equals 1 minus log x multiplied by dy. Recall the exact equation will be in the form of m dx plus n dy equals 0. So we are going to rearrange the terms to have the right-hand side equals 0. And we get 1 plus natural log x plus y over x times dx plus the natural log x minus 1 dy equals 0. Therefore, the m is 1 plus log x plus y over x, and the n is natural log x minus 1. Next, we are going to check the criterion, whether this is an exact equation or not, by finding the partial derivative of the m with respect to y, and to get 1 over x, and also find the partial derivative of the n with respect to x, which is 1 over x as well. So therefore, this is the exact equation. Next, we find the solution. To find the solution, we call the partial of the solution with respect to x is the expression m, which is 1 plus natural log x plus y over x. And also the partial derivative of the solution with respect to y is the n expression, or natural log x minus 1. So we are going to find the antiderivative of either m or n to get the solution. So I'm going to work on the n expression. So the function fxy, excuse me, or the solution is the antiderivative of log x minus 1 with respect to y plus the function hx plus the constant of integration. Therefore, our fxy is y times natural log x minus y plus the h of x. The next step, we are going to find the partial derivative of the solution with respect to x and let them equal to the m expression. So the partial derivative of the solution, which is y natural log x minus y plus hx with respect to x equals the m expression, or 1 plus natural log x plus y over x. On the left-hand side, after we find the derivative with respect to x, we will get y over x plus the h prime of x equals the right-hand side, which is 1 plus natural log x plus y over x. That gives us the h prime of x equals 1 plus natural log x. To find h of x is the integral of 1 plus natural log x with respect to x. On the side here, we are going to find the integral of 1 plus natural log x dx. Integral of the 1 dx is x. For the integral of natural log x with respect to x, we are going to use bypass technique from Liate, L-I-A-T-E. The natural log x is the log function, and then 1 as the algebraic, or 1 dx. We let u be log x and 1 dx as a dv. This time we cannot use a tabular bypass because the u is not polynomial function. We use the traditional bypass, the u times v minus integral v du. So as u is natural log x, so the du is 1 over x dx, and the v would be x. Therefore, the integral of the log x would be u times v, or x times natural log x minus the integral of the v du, since the v is x and the du is 1 over x dx. That will give us x plus x log x minus x. X and x cancel. We get x times natural log x as the function hx. Next, write it as the final step. The general solution is of the form fxy equals c, or y natural log x minus y plus x natural log x equals the constant c.